Team Octane Incube welcomes you. In the last episode, we discussed launch from Earth and minimum cost trajectory to arrive Mars. Now, we will discuss landing on Mars. The challenge of entry, descent and landing is how to get something of 500 kilograms or half a ton traveling at 19,300 kilometers per hour Oregon, 12000 miles per hour, slowed down in 6 minutes to have a chance of survival. High velocity entry into Martian air creates a CO2, N2 plasma, as opposed to O2, N2 for Earth air. Mars entry is affected by the radiative effects of hot CO2 gas, and Martian dust suspended in the air. Mars doesn't exactly put out a welcome mat. Landing is complicated by difficult terrain. The Martian surface is full of obstacles, massive impact craters, cliffs, cracks and jagged boulders. Unpredictable winds can also stir up further complications. MEDLI-2, abbreviation for the Mars entry, descent, and landing instrumentation 2, sensor suite collected data about Mars atmosphere during entry, and the terrain relative navigation system, autonomously guided the spacecraft during final descent. The data from both are expected to help future human missions land on other worlds more safely and with larger payloads. As we all know that the space environment isn't friendly. Hazards range from what engineers call single event upsets, as when a stray particle of energy passes through a chip in the spacecraft's computer causing a glitch and possibly corrupting data, to massive solar flares that can damage or even destroy spacecraft electronics. If getting to Mars is hard, landing there is even harder. Descent and landing is 6 minutes of terror. While descending, it enters the Martian space traveling 19,300 kilometers per hour Oregon, 12000 miles per hour. During the first 4 minutes into descent, friction is used with the atmosphere to slow down considerably. However, at the end of this phase, it still is traveling at 1,600 kilometers per hour, or 1,000 miles per hour, but now only 100 seconds are left, and are at the altitude that a commercial airliner typically flies. Things need to happen in a hurry. A parachute opens to slow the spacecraft down to only 321 kilometers per hour, or 200 miles per hour, but now only 6 seconds are left, and are only 91 meters, or 100 yards off the ground. There is heat shield, a part of the thermal protection system, and aeroshell designed to encapsulate and protect the rover and landing system from the intense heat generated during descent into the Martian atmosphere. The retro rockets fire to bring the spacecraft down to zero velocity, at the height of a 4-story building above the surface. And then the rover lands. In the next episode, we will discuss Perseverance in detail, and why Jezero crater is chosen as the landing site on Mars.